Logarithms and Progression. Hello student, welcome to the lecture on logarithms and progression, and after this lecture we will be able to learn the following objectives. Appreciate definition of logarithm, give details laws of operations, describe change of base, explain arithmetic progression, talk about geometric progression, explain geometric mean. Introduction of logarithms. Welcome students, here we will discuss on the topic logarithms and progression. So let us start with the meaning and definition of logarithm. Logarithms are simply the powers or the indices to a given base. Once we have converted values into logarithms to a given base, we can perform difficult mathematical operations of multiplication by addition of logarithms and division by subtraction of logarithms, and like that the other higher order operations. Similarly, problems on involution and evolution are reduced to those of ordinary multiplication and division. Logarithms are in fact corollary to the theory of indices. In order to understand the theory and the application of logarithms, a thorough knowledge of indices and laws governing them is essential. Definition of logarithms. The logarithm of a number to a given base is the index or the power to which the base must be raised to produce the number, that is, to make it equal to the given number. Laws of operation. Now we will talk about the laws of logarithm and how to apply it. Laws of logarithm m, which are valid for any base a, is less than 0 but not equal to 1. Since the term proves the logarithm is merely a substitute 0 for the term index, the laws of logarithms can be easily deducted from the laws of indices. Logarithm of the product of two numbers is equal to the sum of the logarithms of the numbers to the same base, that is, log mn is equal to log m plus log n. The logarithm of a number to the base e is equal to 2.718 approximately, is called natural logarithm or the Neperian logarithm. The logarithm of a number to the base 10 is called common logarithm or Briggsian logarithm. In theoretical calculations, the base e is used, whereas for numerical calculations, the base 10 is most convenient. The tables that are given at the end of the book are all calculated with 10 as base. When no base is mentioned, it is understood to be 10. That is, by the word logarithm, we generally mean common logarithm. Arithmetic progression. After clarifying the basic meaning, definition and laws of logarithm, let's move on to the arithmetic progression. So, an arithmetic progression is a sequence whose terms increase or decrease by a constant number called the Konman difference. A series in arithmetic progression thus becomes an additive series in which the common difference can be found by subtracting each term from its preceding one. For clarification of formula, please watch the video. The first term and common difference are known, the AP completely known, the arithmetic progression a plus 1d, a plus 2d, a plus 3d, whose first term is a and the common difference is d, is designated as the standard form of an arithmetic progression. The corresponding arithmetic series a plus d plus a plus 2d plus a plus 3d plus is designated as the standard form of an arithmetic series. The abbreviation AP for arithmetic progression is commonly used. Definition of arithmetic progression. If for a sequence un plus 1 minus un remains constant for all natural numbers n, then the sequence is called the AP and the numerical difference between two consecutive terms un plus 1 is called the common difference of the AP. The nth term of an AP, let A be the first term and D be the common difference. Then first term u1 is equal to A, second term u2 is equal to A plus D, and third term u3 is equal to A plus D is equal to A plus 2D. Seventh term u4 is equal to A plus 5D plus D is equal to A plus 6D. Nth term un is equal to A plus n minus 1 D, which is also the term indicated by 1. This nth term is called the general term of the standard AP, as by giving n the values 1, 2, 3, 4, the successive terms of the AP can be obtained. Notes: definition of arithmetic progression. If for a sequence un plus 1 minus un remains constant for all natural numbers n, then the sequence is called the AP, and the numerical difference between two consecutive terms un plus 1 is called the common difference of the AP. The nth term of an AP, let A be the first term and D be the common difference. Term u2 is equal to A plus D, and third term u3 is equal to A plus D is equal to a plus 2D. Then first term u1 is equal to A second to seventh. Seventh term u4 is equal to A plus 5D plus D is equal to A plus 6D till nth term un is equal to A plus n minus 1 D, which is also the term indicated by 1. This nth term is called the general term of the standard AP, as by giving n the values 1, 2, 3, 4, the successive terms of the AP can be obtained. Geometric progression. What is geometric progression? Now we will discuss the topic geometric progression and find out the answer of this question. A geometric progression is a sequence whose terms increase or decrease by a constant ratio called the common ratio. A series in geometric progression thus is a multiplicative series whose common ratio can be found by dividing any term by its preceding term. Thus, the sequence 1, 2, 4, 8, 16, 32 is an infinite geometric progression. The first term is 1 and the common ratio is 2. Similarly, the sequence 1, 1 by 2, 1 by 4, 1 by 8, 1 by 16 is a geometric progression. The first term is 1 and the common ratio is 1 by 2. The sequence 5, minus 10, 20, minus 40, 80 is a geometric progression. The first term is 5 and the common ratio is minus 2. The sequence 27, minus 9, 3, minus 1, 1 by 3 is a geometric progression. The first term is 27 and the common ratio is minus 1 by 3. Definition of geometric progression. If for a sequence un plus 1 by un remains constant for all natural numbers n, then the sequence is called GP, and the constant ratio of two consecutive terms un and un plus 1 is called the common ratio of the GP. We can also state the series as Sn minus A plus AR plus AR2 plus AR3 plus till ARn minus 2 plus ARn minus 1. The sequence has the property that the ratios of successive terms are equal. Thus, if u1, u2, u3 till un are the terms of a GP, then u2 by u1 minus u3 by u2 minus u4 by u3 so on till minus r, known as the common ratio. Multiplication of these terms yields un by u1 minus r powered by n minus 1 or un minus u1 r powered by n minus 1. Thus, the nth term un is equal to ar powered by n minus 1. Geometric mean. Here we will talk regarding the geometric means and where it should be inserted or used. When any number of quantities forms a GP, the quantities lying in between the first and the last are called the geometric means. In particular, if we take any three quantities of a series in GP, the middle term is known as the geometric mean GM between the other two. Let G be the geometric mean between A and B. Then A, G, B will be three terms of an order set in geometric progression so that G by A is equal to B by G, implies G2 is equal to AB, implies G is equal to divide by AB. For example, if 4, 8, 16 are consecutive terms in GP, then 16 by 8 is equal to 8 by 4. That is, 64 is equal to 4 into 16. 8 is equal to divide by 4 into 16. Insertion of geometric means. Let G1, G2 till Gn be the n geometric means between A and B. Then A, G1, G2 till Gn bear in GP. Let R denote the common ratio of this GP. Including the given terms A and B, there are n plus 2 terms in this. Therefore, B is equal to n plus 2 term of the GP is equal to AR powered by n plus 2 minus 1 is equal to AR powered by n plus 1, implies R powered by n plus 1 is equal to B by A. That is, R is equal to B by A powered by 1 divided by n plus 1 or n plus 1 in square root of B by A. Therefore, G1 is equal to AR is equal to A B by A powered by 1 divided by n plus 10. G2 is equal to AR2 is equal to A B by A powered by 2 divided by n plus 1. G3 is equal to AR3 is equal to A B by A powered by 3 divided by n plus 1. G3 is equal to AR powered by n is equal to A B by A powered by n divided by n plus 1 respectively. Summary. In the end of this chapter, let's summarize the topics. The conversion of values into logarithms is, however, no problem since ready-made conversion tables are available for the purpose. With little practice, the use is very easy. The logarithm of a number to a given base is the index or the power to which the base must be raised to produce the number. The logarithm of any quantity to the same base is unity. This is because any quantity raised to the power 1 is that quantity only. Since a powered by 2 is equal to a is equal to greater than log a is equal to 1. A series in arithmetic progression thus becomes an additive series in which the common difference can be found by subtracting each term from its preceding one. If for a sequence un plus 1 by un remains constant for all natural numbers n, then the sequence is called GP and the constant ratio of two consecutive terms ux plus 1 called the common ratio of the GP.